Smartphones contain a compact metal cylinder, the lithium-ion battery. This battery stores significant energy in a small space. Lithium-ion batteries are essential for modern electronics. They provide the power source for portable devices. Their high energy density makes them ideal for smartphones. Laptops commonly use lithium batteries. Lithium batteries provide portable power. This highlights lithium battery technology's prevalence. Laptops benefit from the energy density. Lithium batteries contribute to laptop portability. Their widespread use shows technological reliance. Electric vehicles, such as Teslas, rely on large lithium battery packs. These battery packs are essential for providing long-range driving. Lithium batteries enable electric vehicles to travel considerable distances. This capability is crucial for the practicality of electric transportation. Battery technology is a key factor in the advancement of electric vehicles. Lithium is extracted from underground brine pools. Salty water, rich in lithium, is the primary source. This lithium-rich brine is pumped to the surface. The pumped brine undergoes processing. Processing extracts lithium compounds for various uses. Extracted brine is transferred to large evaporation ponds. The brine remains in these ponds for several months. Solar evaporation gradually reduces the water volume. As water evaporates, the lithium concentration increases. This process continues until the lithium reaches desired levels. Concentrated lithium undergoes processing in a chemical plant. The primary output is lithium carbonate, a key battery component. Lithium hydroxide is another crucial compound produced. Both lithium carbonate and hydroxide are vital for batteries. These compounds enable efficient energy storage in batteries. The process refines raw lithium into battery-grade materials. Graphite is used as the anode material in batteries. Refining graphite is essential for achieving high purity. High-purity graphite is needed for optimal battery performance. The refining process removes impurities from the raw graphite. Refined graphite enhances battery efficiency and longevity. Metals like nickel and cobalt are essential components in battery cathodes. These metals undergo processing to meet strict battery manufacturing standards. The purification process removes impurities from the raw materials. High purity levels are crucial for optimal battery performance and longevity. This ensures the cathode materials meet the required specifications. Powdered cathode materials are prepared for electrode production. These materials are mixed with solvents in a controlled environment. Binders are added to the mixture to enhance cohesion. The combination of materials forms a thick paste known as slurry. Slurry is a critical intermediate in the electrode manufacturing process. The slurry's consistency and composition are key to electrode performance. Anode slurry preparation is crucial for efficient battery operation. A separate slurry is made specifically for the anode material. This slurry primarily consists of graphite, a key component. The mixing process ensures correct material composition. Achieving the right consistency is also a critical factor. Proper slurry properties contribute to efficient battery performance. Cathode slurry is applied to thin aluminum foil in battery manufacturing. The aluminum foil serves as a current collector within the battery cell. This coating process is crucial for the battery's functionality. The slurry evenly distributes active materials on the foil. Precise coating thickness ensures optimal battery performance. The coated foil is then processed further into battery electrodes. Anode slurry is applied to a thin copper foil substrate. Copper foil serves as a current collector in the battery. The coating ensures proper electrical conductivity. This conductivity is crucial for battery performance. The coated foil becomes a key component of the anode. Coated sheets move through drying ovens. The drying process removes solvents from the coating. This removal leaves a solid electrode material. The ovens are long to ensure thorough drying. Calendering involves compressing materials using heavy rollers. This process occurs after the material has been dried. The compression increases the material's density. Calendering also ensures a consistent thickness throughout the material. Large sheets are processed by a cutting machine. The machine cuts the sheets into strips. The machine can also cut the sheets into shapes. The cutting process ensures precision. The strips, shapes are prepared for battery cell assembly. A separator film is a thin plastic layer used in battery production. Its primary function is to prevent direct contact between the cathode and anode. This separation is crucial to avoid short circuits within the battery cell. The separator film ensures proper ion flow while maintaining electrical insulation. The stacking machine is used for prismatic or pouch cells. It stacks layers flat to create the cell structure. This process ensures accurate alignment of the layers. Precise spacing between layers is also also maintained. Flat stacking is crucial for cell performance. Consistent layer arrangement is vital for quality. Cylindrical cells use a spiral rolling method for compact design. Layers are tightly rolled into a spiral. This maximizes space utilization within the battery. Common cylindrical cell types include 18650 and 21700. The rolling technique is key to their efficient energy storage. The process begins with the insertion of electrodes. Electrodes are placed inside a protective casing. The casing is typically made of metal. Aluminum is also a common casing material. This assembly forms the basic battery cell structure. The cell is moved to a dry room. This room maintains near zero humidity levels. Low humidity prevents moisture damage. This protects sensitive battery components. Electrolyte, a liquid solution, is injected into the battery cell. The injection occurs under vacuum conditions to ensure proper filling. This process facilitates the movement of lithium ions. Lithium ions move between the electrodes within the battery cell. Batteries are arranged on large racks. They undergo an initial, slow charging process. This first charge is crucial for battery performance. It initiates the formation of the SEI layer. The SEI layer is critical for battery stability. Batteries undergo strict testing to ensure quality and performance standards are met. Voltage accuracy is tested to verify the battery operates within specified limits. Capacity testing determines the amount of energy the battery can store and deliver. Self-discharge rate is measured to assess how quickly the battery loses charge when not in use. Individual cells are combined to form modules. Modules are assembled into battery packs. Battery packs are used in electric vehicles. Battery packs are also used in other applications. Assembly lines facilitate battery pack production. Fully tested batteries are shipped worldwide from distribution centers. These batteries power a wide array of devices and systems globally. Applications include smartphones, laptops, and electric vehicles. Batteries also support solar energy storage, enhancing renewable power use.